Now, unlike reflection, where the ray hits an obstacle and is sent back, right? In refraction, the ray enters into the second medium. It travels from one medium, in this case air, and enters into the second medium, which is glass. So whenever a ray of light travels from one medium to another medium of different densities, right, the ray or the wave experiences a change in speed and direction. Like we can see here, ray PQ, this ray PQ enters into the glass. It is coming from air and it enters into the glass. These are two different media of different densities, right? It could be water and glass, it could be air and glass, just two different media of different densities. However, it could also be a single medium like air. So if you have two layers of air and a ray travels from one layer, which is hotter, to another layer, which is cooler, then it's also going to be refracted, since the two media now, the hotter air and the cooler air, are of different densities. So when a traveling wave travels from a medium to another medium and they are of different densities, it is going to be refracted at the boundary between the two media. So in this case, when ray PQ enters into the second medium, which is glass now, it is going to be refracted. That means it's going to experience a change in its speed and direction. You see, it would be ideal for us, therefore, to describe refraction as a change in speed and direction of a wave at the boundary between two media of different densities. So the properties of the traveling wave that will change as it enters into the second medium are the speed will not remain the same, the direction will not remain the same. The same thing, the wavelength will not remain the same. So those are the three things that will change about the wave. Its speed, its direction, and the wavelength. All right. Now, you will recall that the angle between the incident ray PQ and the normal NQ is called the angle of incidence, I. Whereas the angle between the refracted ray, this RQ, this ray, and the normal is called the angle of refraction. So we have the angle of incidence and the angle of refraction. The angle of incidence I and the angle of refraction R. And do not forget, even though the bulk of the ray is refracted, a weak part of it is reflected, a very small part of it is reflected. So we say, even though we're having refraction, you still have a weakly reflected ray. Weakly, take it. The bulk of the ray is refracted, the much of the ray is refracted, only a fraction of it is reflected. So there's also an angle of reflection here. Just as you have the angle of incidence, you also have the angle of refraction, and here's an angle of reflection. Keep that. It is not in this diagram, but we'll get to use it sometimes later. Now, let us explain what we now have on the screen. PQ, ray PQ is the incident ray. Ray QR is the refracted ray. Ray RS is the emergent ray. Angle I here, like you know, is the angle of incidence. Angle R is the angle of refraction, and angle E is the angle of emergence. Now, imagine PQ traveling without the block ABCD here. It implies that PQ will continue its path on this straight line, that dotted line. PQ will continue its path on that dotted line, undeviated. But because it has entered into a new medium, the glass now, the path will change. That change in the direction, that deviation in its direction is what angle D represents. So angle D is the angle of deviation. Now, however, if we produce this dotted line, that straight line, it is going to be parallel to line RS, ray RS, the emergent ray. So eventually you see that the incident ray and the emergent ray are parallel. There's no deviation between the two. There's no deviation between the incident ray PQ and the emergent ray RS, because the two rays will be parallel rays, parallel lines. And the last part we need to understand before we leave this aspect is that when a ray travels from an optically dense medium to a denser medium, glass is optically denser than air. So when a ray travels from an optically dense medium, which is air, to a denser medium, which is glass, it is going to be refracted towards the normal. You can see obviously that ray QR, the refracted ray here, bends towards the normal. Normal is this dotted line. So the ray bends towards the normal, all right? But when the ray travels from a denser medium, an optically denser medium, to a dense medium, then it is going to be refracted away from the normal. Look at the normal at this other part when the ray comes from glass to air, all right, this emergent ray. Because what happens here is also refraction. The ray is coming from one medium to another medium. So when this happens and it travels in such a case, like from glass to air, glass is denser than air, like I said, that ray will be refracted away from the normal. So finally on this aspect, you know that when a ray travels from one medium to another medium, it experiences a change in speed, a change in direction, and a change in its wavelength. The speed will change, the direction will change, the wavelength will change, but the frequency will remain the same. Frequency is unchanged.